Welcome back to Canna Intel 420, where we go beyond surface-level cannabis culture to uncover the science, history, and design behind the plant itself. This series, Beyond the Indica Sativa myth, breaks through decades of misconception to show how chemistry, environment, and human intention shape what we experience today. So, whether you're a grower, educator, or simply curious about how far the plant has evolved, you're in the right place, and we're just getting started. But before we get started, we need to do the legal stuff we all know and love. This content is for educational and informational purposes only. It does not promote or encourage the use, sale, or cultivation of cannabis where prohibited by law. All discussion pertains to cultural, agricultural, and chemical literacy. You know it. Now, let's begin. The story of Maui Wowie begins in isolation, both geographic and generational. In the early 1970s, Hawaii sat at the intersection of agrarian heritage and post-war counterculture, a place where American escapism met Pacific ecology. Cannabis there was not imported contraband, but cultivated flora, nurtured in volcanic loam under one of the most stable light cycles on Earth. The island's latitude produced a 12-hour equilibrium of day and night nearly year-round, enabling tropical varieties to flower naturally without artificial correction. The plants that adapted to these conditions didn't just survive. They rewrote their own physiology to match an environment defined by constancy rather than fluctuation. What grew from this ecological stability was a lineage that looked and behaved unlike the compressed imports from Mexico or Colombia that dominated the mainland. The phenotype, later labeled Maui Wowie, emerged from acclimatized Southeast Asian genetics that had traveled the Pacific through informal seed exchange. Under the island's maritime humidity, these tall, narrow-leafed plants evolved lighter, more porous floral structures to regulate moisture and temperature. Where Afghani cultivars formed dense, resinous clusters to conserve heat, Maui varieties spread open and airy, preventing microbial bloom in persistent humidity. Morphology became the language of adaptation. Hawaii's volcanic substrate shaped chemistry as directly as sunlight shaped form. The soil's mineral profile, silica, potassium, magnesium, trace sulfur, created nutrient ratios that favored terpene biosynthesis over cannabinoid concentration. Analytical testing of preserved samples decades later would show elevated levels of limonene, beta-pinene, and terpinolene, molecules associated with high solar exposure and pest deterrence. The tropical scent attributed to Maui Wowie is not a stylistic note, but a geochemical artifact, a plant encoding its surroundings in volatile compounds. Each terpene reflects a physiological response to radiation, humidity, and atmospheric pressure rather than a selective human preference. To the generation that named it, however, chemistry was less important than narrative. The 1970s were defined by distrust of institutions and fascination with authenticity, handmade, unregulated, and untamed. Maui Wowie entered American consciousness as an unbranded expression of that ethos. It wasn't sold as a commodity, but traded as a story, a promise of sun-grown purity from a place untouched by industrial logic. Its cultural power came from scarcity and distance, the idea that true cannabis still existed somewhere outside the reach of commercialization. That myth thrived because the plant itself reinforced it. Every batch looked and smelled slightly different, a sensory argument against standardization. From a scientific perspective, that inconsistency was a natural outcome of microclimate variation. Temperature gradients between coastal and upland sites produced different terpene and cannabinoid ratios. Plants grown near the ocean developed higher monoterpene content due to salt and UV stress, while those in shaded valleys expressed heavier sesquiterpenes for microbial defense. The diversity that consumers romanticized as character was, in fact, the signature of environmental feedback, an unintentional dataset written in aroma and density. In a way, Maui Wowie was the first cultivar to demonstrate that cannabis could be used as a sensor, a biological recorder translating geography into chemistry. Yet, that freedom carried a paradox. The same environmental openness that gave Maui Wowie its individuality also made it impossible to replicate. Once its seeds reached California, the mainland's drier climate and artificial lighting compressed its profile. The bright, resinous tang softened. The plant's metabolism, tuned to continuous humidity and volcanic minerals, no longer functioned the same. Growers tried to stabilize it through selective breeding, but the attempt to preserve freedom produced control. The era of wild cultivation was ending, replaced by a system that rewarded precision and predictability over discovery. Culturally, Maui Wowie represents the threshold between intuition and methodology, the last generation of cannabis shaped primarily by environment rather than intention. It stands as evidence of what happens when a plant evolves through coexistence instead of manipulation. It was neither a product of science nor superstition, but of observation, a living equilibrium between sunlight, salt, and soil. What made it legendary wasn't potency or nostalgia, but the lesson it carried, that cannabis chemistry was once written by climate, not calculated by formula. And it is precisely that contrast, spontaneous adaptation versus controlled design, that defines the frontier GMO cookies would later cross. If Maui Wowie was born from geography, GMO cookies was manufactured from intention. Its origin sits at the opposite pole of cannabis evolution, not a landscape, but a laboratory of logic. Where 1970s growers relied on soil and sunlight, GMO cookies emerged from algorithmic lineage tracking, phenotype mapping, and iterative hybridization. The architecture of control was made visible through the plant. Developed in the 2010s by breeders focused on extreme terpene concentration and structural uniformity, GMO cookies embodies the transition from cultivation to design. It is cannabis no longer grown from instinct, but engineered through selection pressure measured in data points and chromatograms. The name itself reflects a shift in cultural syntax. Garlic, mushroom, onion. Its initials are a sensory warning, is not a marketing flourish, but a declaration of precision. It rejects the romantic softness of tropical naming for the blunt specificity of chemistry. The aroma, dominated by sulfurous thiols and volatile organosulfur compounds, reveals an intentional pursuit of molecular rarity rather than sweetness. The breeder's goal was to invert expectation, to create a cultivar so chemically dense it disrupted the industry's addiction to fruit and dessert profiles. Where Maui Wowie embodied spontaneity, GMO cookies represented calibration, each molecule accounted for, each expression cataloged. This shift in design philosophy traces directly to the scientific advances of the late 2000s. Gas chromatography and high-performance liquid chromatography had become accessible to private breeders, transforming aroma from mystery into a measurable variable. Terpene data moved from descriptive folklore to quantifiable metrics, and flavor became a function of reproducibility. Breeding was no longer the art of chance crossing, but the discipline of probability, the deliberate alignment of parental chemotypes to achieve target ratios. The cross that produced GMO cookies, ChemDog mixed with Girl Scout cookies, exemplified this model. ChemDog contributed volatile thiols and hydrocarbon density, while GSC stabilized resin structure and flowering time. The resulting cultivar carried both the chemical aggression of its father and the market appeal of its mother. Unlike its predecessors, GMO cookies did not inherit a single regional identity. It was the offspring of a globalized network, genetics traded through forums, breeder circles, and clone exchanges. The plant's terroir was metadata, spreadsheets, spectral analysis, and climate-controlled replication. In this environment, authenticity became procedural rather than geographic. Growers replicated conditions, not soil. Light spectra, humidity curves, and nutrient solutions were programmed to maintain molecular consistency. The environment stopped shaping chemistry. Chemistry began dictating the environment. Each grow was a controlled experiment designed to confirm fidelity to the original profile. The irony is that this precision produced both purity and fragility. GMO cookies thrives under narrow environmental parameters. Minor deviations in temperature or humidity can disrupt its terpene balance. The very uniformity that made it a commercial success also removed its ability to adapt. Its thick resin layer, celebrated for density and bag appeal, is an evolutionary liability outside controlled environments, prone to mildew in unfiltered air and slow to transpire moisture. The plant's perfection exists only within the artificial climate that created it. Outside of that context, it loses equilibrium. Culturally, this dependence reflects a broader technological psychology, faith in optimization over variability. In a market obsessed with metrics, percentage, potency, yield, GMO cookies became a symbol of quantifiable excellence. Its cannabinoid concentrations often exceed 25% delta-9 THC, paired with consistent terpene expression between 2–4% total volume. Those numbers signified reliability, not experience. Consumers began to equate chemical magnitude with quality, mistaking uniformity for superiority. Yet, GMO cookies is not merely a symptom of over-engineering. It represents the maturation of cannabis as a designed organism, the proof that human intention can sculpt biochemical behavior as effectively as nature once did. Its pungency, its sheen, its structure, all are deliberate outcomes of selection rather than serendipity. In scientific terms, it is a demonstration of heritability management, how breeders can guide the expression of volatile organic compounds through successive generation refinement. In cultural terms, it is the sound of the natural world being tuned to a commercial key. The result is a plant that mirrors the society that built it, efficient, measurable, and optimized for scale. GMO cookies is agriculture without geography, chemistry without chance, and culture without myth. Its existence doesn't invalidate the freedom of Maui Wowie. It defines what came after freedom was systematized. It is the logical endpoint of the same curiosity that once drove exploration, a plant that no longer asks where it comes from, only whether it performs as expected. Tracing the genetic lineage of Maui Wowie is less an act of genealogy than of reconstruction. The cultivar arose during an era when cannabis traveled not through seed banks or digital archives, but through pockets, backpacks, and human memory. Its evolution was undocumented, its ancestry scattered across continents that no longer share agricultural continuity. The most credible evidence points to Southeast Asian origins, likely Thai or Cambodian landraces, whose seeds migrated through informal trade routes carried by soldiers and travelers during the late 1960s. When these tropical genotypes reached Hawaii, they entered an environment that favored selection over breeding. No one was crossing plants deliberately. Survival itself was the cross. The island's climate performed the work of genetic editing. Photoperiod uniformity forced these imported varieties to adapt to consistent 12-hour days, gradually selecting for phenotypes that flowered efficiently under constant light exposure. Over several generations, local growers learned to recognize plants with narrow internodal spacing, high node count, and thin petioles, structural adaptations that mitigated heat stress and maintained respiration under dense humidity. What became known as Maui Wowie was not one strain stabilizing over time, but a moving equilibrium, a community of related phenotypes shaped by the same environmental algorithm. This unintentional selection created an ecological filter that sculpted chemistry alongside structure. The intense ultraviolet radiation at mid-altitude forced plants to express higher concentrations of antioxidant terpenes such as terpinolene and beta-pinene, which protect cellular membranes from oxidative stress. At the same time, consistent air circulation from oceanic wind reduced fungal competition, allowing the plant to allocate more metabolic energy to volatile compound synthesis rather than immune response. The result was a chemotype characterized by high aromatic diversity and moderate cannabinoid levels, a profile driven by survival rather than potency. In genetic terms, this adaptive diversity preserved heterozygosity. While modern breeding often narrows genetic variation to achieve predictability, Maui Wowie maintained a broad allelic range, allowing it to display micro-adaptations from one valley to the next. Two plants sharing the same seed lineage might diverge in flowering time, aroma, and resin density based on nothing more than altitude or soil mineral content. These variations made Maui Wowie resilient against pests and environmental change, but impossible to standardize, a quality that frustrated early commercial growers and fascinated ethnobotanists studying cannabis as an adaptive species. The 1970s brought the first serious attempts to reproduce Maui Wowie outside its home climate. California's coastal cultivators sought to replicate the tropical morphology, but lacked the consistent humidity and volcanic nutrient balance. To compensate, they crossed surviving Maui phenotypes with Colombian and Mexican plants that performed better in temperate light cycles. These efforts produced hybrids that mimicked the aroma but lost the structural traits that defined the original, a sensory facsimile without ecological authenticity. The industry began to treat Maui Wowie as a flavor rather than a genotype, abstracting its identity into marketing language while the true landrace continued mutating quietly in Hawaiian soil. By the late 1980s, the global cannabis trade had shifted toward high-yield Afghani hybrids, and Maui Wowie receded into niche cultivation. Yet, its genetic legacy persisted in subtler forms. Many early hybrid programs drew from its tropical lineage to balance the sedative weight of indica-dominant crosses. Traces of its terpene inheritance can be found in later cultivars like Island Sweet Skunk, Pineapple Express, and Super Silver Haze, all inheriting the same volatile, high-limonene signatures that once defined Maui's fields. Even as its name became diluted through imitation, its genetic logic, tall architecture, long internodes, terpene-driven adaptation remained embedded in the modern genome. In a scientific sense, Maui Wowie represents a transitional clade between wild landrace populations and human-directed hybrids. It bridges the period when cannabis still responded primarily to environmental selection before genetic intervention became dominant. This distinction matters because it captures a living record of how unregulated evolution shapes chemical complexity. Where modern hybrids often sacrifice secondary metabolite diversity for consistency, Maui Wowie shows the opposite outcome, variation as resilience. Its lineage is a textbook example of adaptive radiation within constrained geography, a microcosm of evolutionary dynamics accelerated by human neglect rather than design. Understanding its genetic story reveals why Maui Wowie cannot be truly recreated in laboratories or replicated by cloning. Each plant was a statistical outlier made viable by climate, soil, and time. The genetic mosaic that made it thrive exists as a dispersed memory across descendant hybrids, fragments of alleles that once conspired to translate sunlight into fragrance. Its disappearance was not extinction, but absorption, a slow diffusion of tropical genetics into the hybrid era, leaving behind only a name that now stands as cultural shorthand for an ecosystem's vocabulary. The genetic blueprint of GMO cookies represents the full realization of human-directed cannabis evolution. Unlike Maui Wowie, whose lineage scattered through ecological happenstance, GMO cookies was purpose-built through the intentional alignment of two distinct chemotypes, Chemdog and Girl Scout cookies, GSC, each selected for their opposing but complementary traits. Where one contributed volatility and raw chemical aggression, the other brought refinement and structural coherence. The cross was not casual experimentation but strategic design, an attempt to fuse high terpene density with market-stable architecture, creating a cultivar capable of consistent potency under mechanical precision. Chemdog, believed to trace its ancestry to early U.S. underground breeding in the 1990s, was already a legend of unpredictability. It expressed erratic growth patterns, unstable morphology, and a pungent hydrocarbon odor due to elevated thiol and terpinolene levels. Its chemical volatility made it a benchmark for sensory intensity, but a nightmare for commercial cultivation. Girl Scout cookies, conversely, was the product of refinement, a descendant of OG Kush and Durban, poison stabilized through repeated inbreeding to produce predictable trichome development, consistent flowering cycles, and a dessert-like aromatic profile dominated by caryophyllene and limonene. Crossing these two was an act of calculated tension, chaos meeting control. The first-generation hybrids underwent a process resembling modern agricultural genomics, though without formal sequencing. Growers employed iterative selection based on phenotype to chemotype correlation, evaluating how observable traits such as calyx density, anthocyanin expression, and resin viscosity aligned with laboratory terpene readings. Over successive cycles, breeders isolated plants, expressing the rare sulfurous thiol signature of ChemDog while retaining the trichome uniformity of GSC. This process, informally called guided phenotype regression, effectively reverse-engineered consistency from volatility. The resulting genotype stabilized both aromatic intensity and mechanical harvest efficiency, reducing cultivation variability by more than half compared to either parent line. And chemically, GMO cookies became an evolutionary convergence point for two terpene families rarely dominant in the same cultivar. From ChemDog, it inherited the presence of volatile organosulfur compounds, molecules that oxidize rapidly but create the distinctive garlic and fuel aroma that defines the strain. From GSC, it absorbed high beta-caryophyllene and limonene concentrations, lending a smoother, earthy sweetness that buffered the raw intensity of its other parent. The fusion generated a terpene ratio seldom seen before in stable hybrid populations, simultaneous thiol aggression and sweet resin viscosity. It was this duality that established GMO cookies as both an olfactory anomaly and a commercial phenomenon. From a genetic perspective, GMO cookies embodies the principles of polyhybrid compression. Each breeding cycle narrowed allelic diversity while strengthening trait predictability, a process that mirrors domestication in food crops such as maize or wheat. This compression optimized repeatable morphology but reduced genetic elasticity, making GMO cookies highly specialized but environmentally fragile. Its success depended entirely on controlled conditions, vapor pressure deficit management, precise nutrient delivery, and photoperiod calibration. The plant's performance outside its engineered environment declined sharply, underscoring how human intention had supplanted natural adaptability with procedural dependency. Culturally, the consolidation of GMO cookies' lineage coincided with the digital age of cannabis, an era when growers exchanged genetic data across global forums, using digital phenotype libraries to predict breeding outcomes. Reputation replaced geography as the new form of lineage authentication. A cultivar's legitimacy was proven through data consistency and lab results, not terroir or regional folklore. The genetic identity of GMO cookies became a file, portable, transferable, and endlessly replicable. What once required physical preservation through seed banks now survived as metadata in breeder archives. The plant had entered the informational phase of its evolution. This informationalization redefined what lineage meant. The ancestral tree of GMO cookies is less a branching biological diagram than a network of iterative feedback loops, each breeder refining the last breeder's refinement. In that sense, GMO cookies no longer represents a single stable genotype, but a maintained standard, enforced through cultivation protocol, rather than hereditary purity. Its lineage exists as algorithmic agreement, a consensus on how it should smell, grow, and test, rather than a strict genetic inheritance. When viewed alongside Maui Wowie, its lineage tells the story of cannabis's transition from organism to instrument. One line was adapted through exposure, the other was perfected through repetition. Both illustrate evolution, but in opposite directions, one toward resilience, the other toward reproducibility. And within that divide lies the modern identity of cannabis genetics, a species no longer defined by where it grows, but by how faithfully it can repeat itself. The cultural distance between Maui Wowie and GMO cookies is not measured in chemistry or yield, but in worldview. Each cultivar represents a distinct epoch in how society defines value, authenticity, and truth in cannabis. One emerged from a world that believed nature was the final authority, the other from a world convinced that perfection could be manufactured. Together, they trace a transformation in collective psychology, from the organic to the engineered, from cultural myth to scientific branding. Maui Wowie carries the memory of decentralization, a time when cultivation was participatory, when growers were not yet operators, but custodians of local ecology. Its narrative belongs to an era when cannabis symbolized escape from conformity, when its very illegality reinforced the mythology of freedom. In the 1970s, a jar labeled Maui Wowie didn't imply lab validation. It implied faith. You believed the story because belief was the currency of authenticity. Its loose genetics and inconsistent chemistry weren't flaws. They were proof that the plant was alive, unmeasured, and unowned. By contrast, GMO Cookies inhabits the era of traceability, every phenotype tagged, every batch verified, every percentage itemized. Its identity is fixed by certificate, its consistency enforced by technology. It exists within a culture that treats biology as code, editable, reproducible, and subject to optimization. What Maui Wowie communicated through myth, GMO Cookies communicates through metrics. Both claim legitimacy, but one relies on trust in nature, while the other relies on trust in process. This divergence is not accidental. It reflects the same cultural schism that transformed food, art, and medicine, the shift from experience-based understanding to data-based belief. The irony is that both forms of trust are illusions. Maui Wowie was never genetically pure, and GMO Cookies is not chemically absolute. Each exists as a moving target, a temporary consensus of what the plant should be, shaped by human desire more than genetic truth. The romanticism of Maui Wowie and the precision of GMO Cookies both conceal a deeper truth. Cannabis has always been a mirror. Its meaning changes not because the plant evolves faster, but because human intention does. The idea of strain itself as a stable, repeatable identity is a cultural fiction born from the need to categorize what was once wild and unpredictable. But the social implications reach beyond marketing. The trajectory from Maui Wowie to GMO Cookies parallels a larger human narrative, the migration from ecology to economy. In the 1970s, cannabis culture was an act of resistance, an informal network rejecting industrial logic. Today, it is industrial logic perfected, with terpene graphs and cannabinoid data serving as the new totems of belonging. The plant once symbolized freedom from systems. Now it symbolizes mastery over them. The irony is not loss of authenticity, but inversion of it, where authenticity itself has become a measurable commodity. Philosophically, these two cultivars describe the arc of cannabis literacy. Maui Wowie teaches that chemistry can arise from chaos, that diversity and unpredictability are natural instruments of survival. GMO Cookies teaches that control has limits, that precision without context breeds dependency. Together, they reveal that cannabis evolution is not simply genetic, but epistemological. It charts how humanity redefines knowledge from experiential wisdom to analytic certainty, and how each definition alters our relationship to the living world. The synthesis of their legacies is neither nostalgia nor futurism, but recognition. Every modern hybrid exists somewhere between these poles, part memory, part algorithm. The cultivars we celebrate today are mosaics of both philosophies, nature's adaptability encoded into human design. And as the myth of Indica and Sativa continues to dissolve, Maui Wowie and GMO Cookies remind us that cannabis was never about polarity at all, but translation, a species forever caught between the language of the earth and the grammar of human invention. Chemistry is where the mythology of cannabis meets its measurable truth, and where Maui Wowie and GMO Cookies become the clearest reflections of two opposing design philosophies. Beneath their cultural narratives lie distinct molecular languages, each telling a story about adaptation, intention, and consequence. One expresses biochemical fluidity shaped by climate. The other displays molecular uniformity dictated by human precision. Together, they form a case study in how cannabis chemistry evolved from environmental feedback to engineered architecture. The chemical fingerprint of Maui Wowie is defined by volatility, not in the sense of instability, but in its natural breadth. Historical chromatographic analyses of legacy Hawaiian samples reveal dominant monoterpenes, including limonene, terpinolene, beta-pinene, and myrcene, with variable expressions of osamine and nerolidol depending on microclimate. This combination produces a terpene ensemble geared toward photoprotective and antifungal functions common in tropical ecotypes. Each molecule serves as an adaptive response. Limonene enhances UV resilience. Beta-pinene and terpinolene deter herbivory and fungal invasion. The cannabinoid ratios mirror this ecological logic. Moderate delta-9 THC concentrations, often between 12 to 16%, balanced with trace CBG and CBC, creating a chemical profile built not for sedation or potency, but for survivability in high radiation, high humidity environments. This chemical ecology is the essence of Maui Wowie's unpredictability. No two harvests were ever identical because each grew as a reflection of its immediate surroundings: sunlight angle, rainfall pattern, mineral flux. In scientific terms, this variability stems from epigenetic plasticity, where gene expression fluctuates in response to environmental stimuli. The myth of sativa energy associated with tropical strains is a cultural interpretation of this physiological reality. Lighter cannabinoid load, higher monoterpene presence, and faster metabolic turnover yield sensory profiles perceived as bright, citrusy, and stimulating. What users framed as psychological distinction was, in fact, environmental chemistry, translated through metabolism. GMO cookies, by contrast, demonstrates the opposite model: chemistry as architecture, built through deliberate concentration. Analytical profiles across verified cultivars consistently show delta-9 THC levels exceeding 25%, coupled with terpene densities approaching 3 to 5% total volume, figures that place it among the most chemically concentrated hybrids ever stabilized. The terpene hierarchy here is inverted from tropical models. Beta-caryophyllene, limonene, and humulene form the structural base, while volatile organosulfur compounds, including thiols such as 3-methyl-2-butene-1-thiol, create the cultivar's unmistakable garlic fuel signature. These thiols, rare in most cannabis chemotypes, arise from the chemdog lineage's unique expression of cysteine-derived precursors, and their inclusion marks a profound shift in breeding philosophy: the prioritization of rarity over balance. In GMO cookies, chemistry no longer mirrors environment, it defines it. Its dense trichome layer and heavy resin saturation require specific vapor pressure, humidity, and nutrient ratios to maintain terpene fidelity. Deviations alter not just yield, but identity. What once evolved in conversation with nature now depends entirely on artificial regulation: photoperiod calibration, CO2 enrichment, and nitrogen modulation. The plant's chemistry has become a closed system, its complexity maintained through human control rather than ecological dialogue. This inversion of agency, the plant adapting to machines rather than machines adapting to the plant, is the defining biochemical hallmark of the modern hybrid era. When compared side by side, the contrast becomes mathematical. Maui Wowie's terpene ratios display a high monoterpene to sesquiterpene proportion, often 3 to 1, producing rapid volatilization and bright transient aroma signatures. GMO cookies reverses this ratio to favor sesquiterpenes and sulfur volatiles, yielding a heavier, slower burning aromatic curve. These physical differences translate directly to perceptual experience. Where one disperses scent quickly and metabolizes cleanly, the other lingers, dense and saturating. The myth of sativa versus indica finds its roots here, a misunderstanding of chemistry's tempo, not its taxonomy. Faster aromatic volatility became associated with alertness, slower aromatic decay with calmness. The plant never changed its neurological target, only its chemical rhythm. This dichotomy extends into cannabinoid synergy. Maui Wowie's modest THC expression allows secondary cannabinoids like CBG and CBC to modulate receptor binding, producing a broader but lighter pharmacological signature. GMO Cookies, bred for saturation, overwhelms that spectrum, maximizing delta-9 THC while minimizing modulatory compounds. The result is a chemical monologue rather than a dialogue, a concentrated statement of potency stripped of environmental nuance. This concentration, while ideal for standardization, narrows the interpretive bandwidth of the plant's chemistry, an inevitable trade-off of control over complexity. From a literacy standpoint, these molecular opposites illustrate the central fallacy of strain culture, that consumer perception can be neatly divided between uplifting and sedating. What actually defines those differences are terpene volatility, ratio balance, and cannabinoid diversity, not genetic mythos. Maui Wowie operates like a chemical spectrum, diffuse, adaptive, open-ended, while GMO Cookies behaves as a chemical algorithm, dense, targeted, and repeatable. Both are brilliant in design, but for opposite reasons. One thrives on variation, the other on precision. The lesson embedded in their chemistry is not about preference, but perception, the recognition that what culture calls effect is merely chemistry's tempo made visible. Cannabis has always been more than the chemistry we measure or the stories we tell. It is a dialogue between what we know and what we choose to believe. In the journey from Maui Wowie to GMO Cookies, we can trace a shift not just in cultivation, but in consciousness. One side of this spectrum speaks through environment, its identity written in salt air, ultraviolet radiation, and the slow patience of climate. The other speaks through design, its character defined by calibration, intention, and precision. Both are legitimate expressions of the same species, yet they occupy opposite ends of human aspiration: freedom and control, wonder and mastery, observation and authorship. To understand Maui Wowie is to understand how ecology writes chemistry. Its irregularity is not a flaw, but a record, a data set written by natural forces before measurement existed. The plant's open genetic structure mirrors the openness of the era that birthed it: unregulated, communal, exploratory. Every variable, from soil mineral balance to photonic exposure, left a molecular fingerprint that shaped its fragrance and its myth. It stands as a reminder that biodiversity was once the baseline of cultivation, and that unpredictability once defined quality. Its very imperfection is what made it real. GMO Cookies, in contrast, stands as a monument to human optimization. Its chemistry is a solved equation, a self-contained system designed for replication. It thrives in uniform light, measured humidity, and consistent input ratios, producing results that validate its design. In this, it represents the culmination of an age that believes mastery of nature equals understanding of it. And yet, the more precise our creations become, the narrower their context grows. Where Maui Wowie adjusted to the world around it, GMO Cookies demands the world adjust to it. This inversion marks the philosophical turn of modern cannabis. The plant no longer adapts to the planet adapts to the plant. Both cultivars, viewed through the lens of literacy, expose the false security of the Indica Sativa binary. What we've been taught to perceive as inherent traits, energetic or relaxing, uplifting or sedating, are cultural echoes of environmental and chemical variance, not biological law. The categories persist because they satisfy the human desire for order, for an illusion that experience can be standardized. But plants do not conform to our labels. The more we learn about their molecular behavior, the more we see that effect is not a type, but a translation, chemistry interacting with context, both environmental and human. The literacy-forward movement in cannabis demands we replace language of myth with language of mechanism. This does not mean stripping away wonder, it means refining it. To speak accurately about cannabis is not to diminish its mystique, but to ground it in truth. Understanding terpene ratios, cannabinoid modulation, or ecological inheritance is not clinical detachment, it's cultural evolution. It's what transforms personal experience into shared knowledge and marketing into education. Every cultivar, from the volcanic resilience of Maui Wowie to the engineered precision of GMO cookies, becomes part of that continuum, proof that cannabis identity has always been relational, never absolute. If Maui Wowie represents the sound of nature singing unaccompanied, then GMO Cookies is that same song arranged in studio form, amplified, compressed, and digitally perfected. Both carry the melody, and neither negates the other. What matters now is whether the audience learns to hear beyond genre. Cannabis literacy is not the abandonment of myth, but its reformation, the act of replacing superstition with structure and nostalgia with knowledge. The Indica Sativa myth dissolves not through argument, but through observation, through chemistry, through time. So, as we move beyond these categories, we return to a simple truth. Cannabis has always been both natural and artificial, wild and cultivated, individual and collective. It evolves because we do, and through it, we see the reflection of our own curiosity, our need to understand the living systems that once seemed unknowable. That is the true inheritance of this plant, not its potency or its prestige, but its ability to mirror the human mind's evolution from belief to comprehension. Thanks for tuning in, everyone. If you found value in this episode, hit that like button, share it forward, and subscribe to help the channel grow. Every bit of support fuels our next deep dive into cannabis literacy and evolution. The more this community expands, the deeper we can go into the science, the culture, and the truth behind the plant. Stay curious, stay informed, and I'll see you all next time. This content is for educational and informational purposes only. It does not promote or encourage the use, sale, or cultivation of cannabis where prohibited by law. All references to chemical composition, plant morphology, or agricultural methodology are presented strictly for cultural, scientific, and historical literacy within lawful educational frameworks. Again, thank you all for watching and keeping me going. Until next time.